A lot of this you probably already know, like for instance what the types of triangles are. Scalene is when you have no sides alike. For example, the easiest way is to draw maybe like a right triangle. And you have one side that doesn't match the other leg, that doesn't match the hypotenuse. Equilateral would be where all sides are the same, or congruent. So maybe something like this, and we would put maybe a tick mark on each one of them. And a key thing to know about this is that they would all have the same angles, and they have to sum to 180, the three of them. So each angle would be 60 degrees in each one of those for an equilateral. Isosceles, and we talked about this already, is where two or more sides are congruent. So easiest way to look at it is something like this, where we've got two sides the same. I'm not going to put anything on the third side because it could be the same, it could be different, it doesn't matter. A couple things to note about an isosceles triangle is the angles that are congruent are the ones across from the congruent sides. Those ones we call base angles. The one that's not a base angle we call a vertex. So let's label this A, B, C. If I told you that A and B is congruent to B, C, what else could you conclude? And that would be that angle A and angle C are also congruent, the base angles. And this would work backwards and forwards. Let me give another little example. Let's say I knew that the angles A and C were congruent. What else could you conclude? The sides across from them are also congruent. So it works kind of backwards and forwards. Let's try a couple examples. I'll give you a little picture. These two are 7. And let's say I gave you that this is 80 degrees, this is X, and this is Y. Can you find X and Y? Pause this movie and find X and Y. To find X, if these two sides are the same, those two angles are the same. So if that's 80, X is 80. And if you have 80 and 80 in a triangle, that's 160 degrees you have in the triangle. You only can have 180 total in a triangle. So that leaves 20 to be the measure of Y. Let's try another example. Another picture, and I'm going to label it, these two are the same, 2 tick marks. One is 10, one I'm going to call Z. This is 50 degrees, X, Y. Find X, Y, Z. Pause this movie, try your best, and then unpause to see the answer. To find Z, if this side is 10, Z is 10. If these two sides are the same, then these two angles are the same. So that means X has to be 50 degrees. If you've already got two 50s inside a triangle, and that totals 100, you have 80 left to be the angle Y. I'm going to just put words now. In triangle ABC, AB is congruent or equal to BC if the measure of angle A is 2x and the measure of angle C is 20 plus x. Find the measure of angle A, the measure of angle B, and the measure of angle C. Pause this, draw a picture, set it up, and see if you can make an appropriate equation. Unpause when you're ready. AB is congruent to BC. I'm going to build it like this so that it's easier to see. AB and BC. A is 2x and C is 20 plus x. So you got to be careful. There's no 180 degrees inside this triangle because we don't have this missing side right here at B. And we already have a variable at A and C. The connection between these two angles is that they're equal. So our equation is going to be where we set them equal to each other. So if x equals 20, I can also go back and say measure of A was 2x. 2 times 20 is 40. Measure of angle B, I don't know just yet. Measure of angle C is 20 plus 20 for the x, which is also 40. Those are supposed to match. If I have 40 and 40 already in this triangle, I take away 80 from 180 and I'm left with 100 degrees for angle B. Let's try one more example. Example number 4. No picture again. In an isosceles triangle, the ratio of the vertex to base angle is 2 to 5. Find all angles. Pause this and try to find the angles yourself. Unpause when you think you're ready. I am going to draw a picture here of an isosceles triangle. If these are my two sides that are the same, these are my two angles that are the same across from them. My vertex would be this one up here. These would be my base angles. Okay. The ratio problems. Did you know that the order you see them is in the order that they are represented in the ratio? So if I dissect this and I say the ratio of the vertex, which is written first, to the base angle, which is written second, that means the number that is written first talks about my vertex, and the number that is written second talks about my base angles. So I'm going to label my vertex with a 2 and my base angle with a 5. Isn't the other one a base angle as well? So I'm going to put a 5 in that spot as well. Now the tricky part is, what do we do from here? We need a variable in there. A ratio means that it's built on this ratio of 2 to 5, but that it's equal amounts. One is going to be 2 times bigger than x, the other one's going to be 5 times bigger than x. If I were to give you this problem where the angles were 5x, 5x, and 2x in a triangle, what's x? You probably would say, well, all of them together add up to how much? 180 degrees, and I get 12x. 180 goes in one time with 60 remaining, maybe 15. Notice it's not any of my answers. My base angles are 5x, which is 5 times 15. I think that's 75 and 75. My other angle is 2x, which is 2 times 15, which is 30. Quick way to check and see if I got the right answer is to add them up, and I get 180 degrees. So these are my 3 angles right here, 75, 75, and 30. You'll be trying more practice problems similar